Okay, I'm going to work the problems in the practice test for Unit 4. So I'll get started. Your first problem says graph the piecewise functions. So what we have here is we have something that's going to have a bunch of y equals. Don't forget these are the values y equals whatever function this is, and in this case we have y equals 8, y equals 3, y equals a negative 5, and those three individual equations are only going to exist for the domain that's specified. So for y equals 8, it's only going to exist where the x values are less than a negative 2. Since they can't equal negative 2, we are going to use an open dot there. So here's x is a negative 2. We're going to go up to where y equals 8. Draw an open dot. And then the values where x is less than a negative 2. For the next piece, we're going to have y equals to 3. And it's going to exist between a negative 2 for x and 4 for x. So a negative 2 for x is here, and we can see it's going to have a closed dot because of the equal to sign. So there is y equal to 3, and it's going to go all the way from x is a negative 2 to x equal to 4. And last, we have y equal to negative 5, where x is greater than 4. Here's a negative 5. Here's where x is equal to 4. Now we can't equal 4, so we're going to use an open dot. Here's the values where x is greater than 4. Next problem. This one's going to be a little bit harder to plot because we don't have nice equations here. You can see that we have a negative 3/4 x plus 5, and that's where x is less than or equal to 2. So that one is going to end over here, and the other one, x minus 3, will start there. So we're going to do that. Since the function x minus 3 is never even going to touch the y-axis, we cannot use the y-intercept and set it up in slope-intercept form. So I'm going to create an xy chart. So let's go y is equal to a negative 3/4 x plus 5, and I need for values that are x is less than or equal to 2. So let's go ahead and make an xy chart for that. Now I need to use the transition point to see what actually happens at 2, so I'm going to put 2 in there. I'll need another point, and it looks like 0 is going to be fairly easy to use, and 0 is less than or equal to 2. So let's plug 2 in. So if I plug 2 into this equation, that's going to be a negative 3/4 times 2. 3 times 2 is a negative 6, all over 2, all over 4, so that's a negative 6/4, that's a negative 3/2. So I would end up with a negative 3/2 plus 5. That would be a negative 1.5 plus 5 should give me 3.5. If I plug 0 in there, I'm going to get 5. Okay, so 2, 3.5. Close dot because I can't equal to 0, 5. Okay, let's do the other. That's x minus 3. And those values of x are greater than 2. So my xy chart, let's go ahead and pick the transition point, which was 2. Now I'm going to have to use an open dot there because x can't equal 2. And I need another value that's greater than 2, so I'm just going to pick 4. So if x is 2, I get 2 minus 3, I get a negative 1. When x is 4, I get 4 minus 3 is 1. So I have 2, negative 1, now that'll be an open dot. And I have 4, 1. Okay, write the equation of the graph function. Now this is going to be a little bit harder. So first thing is let's think about where my parent function is going to be. The parent function would be y equals to the absolute value of x, because I can see that this is an absolute value. It creates a v. So the points on my original function would be, parent function would be xy, and some good points to use would be, let's say, 2, 1, 0, negative 1, negative 2. That would be 2, 1, 0, 1, and 2. So my original graph, the parent function, would have a point here, and a point here, among other points. But let's just look at those. So we can see that this point here, that is 0, 0, because this graph would have looked something like that and continued on. But the point 0, 0 here which is the vertex, has moved up here at a negative 1, 2, 3, and 1, 2, 3, 4, 5. So we can see that what happened is the point 0, 0 shifted to this point, so I can figure that my x shift, I went a negative 1, 2, 3 in the x direction. That means h is equal to a negative 3. I also went 5 up, so k is equal to 5. So I can go ahead and write part of my equation right now. Now, if h is a negative 3, what's in parentheses with the x will be opposite sign, so that's x plus 3 plus k be plus 5. Now I have to see if it's got anything else going on in the front, the multiplication. This would be the y stretch and the reflection, and yes, it is reflected. The absolute value should open up, this one opens down, so I'm going to have a negative in there to indicate the reflection. Now let's see if it's been stretched in the y direction. Let's look at this original parent graph. We can see that I start at 0, 0, I go over 1, up 1. Now if I would reflect that over to here, I would expect, after I flip it, to have a point in those two places corresponding to these 2 points here and here. But I don't. What I really have is I have a point, that point is all the way moved down to that position. So originally, compared to my beginning point, I went down here, 1. Now I'm going down 1, 2, 3, 4. So 1 went to 4, which means it's 4 times greater than what it normally would have been. So I've already taken care of the fact that it's flipped by the negative, so my multiplication, or the stretch factor, will be 4. Let's move over to the next one. Now this is a square root function. You can tell because it just ends. And my parent graph then would have points that I normally use. 9, the square root of 9 is 3. 4, the square root of 4 is 2. 1, the square root of 1 is 1. 0, the square root of 1 is 1. And 0 is 0. So this graph, the parent, would have been located here. So we can see that it's changed quite a bit. The first thing is we're going to find where it was shifted to. So my point here, 0, 0, is now down here at a negative 9, negative 1, 2, 3, 4, negative 4. So I went 9 to the left, so h is a negative 9. And I also went downward vertically, so k is a negative 4. So I can start to fill out my function now, which would be h plus x plus 9 minus 4. So I have put my shift in. Now let's see if we have any stretches or a reflection. Well, notice that this graph, the original green one, which is my parent function, is not reflected over the x-axis. It's not. So there is no reflection there. So my sign would be positive. Now we don't have to show that. We don't have to show the negatives. So there basically is no reflection. And let's see how the points change. Over on my original parent graph, I would go over 1, up 1. So looking at my parent, how it would look if it did not stretch, I'd go over 1, up 1. But I don't have a point there. I have a point right there. So what's happened is this point that had this kind of a distance is now stretched to there. So you can see that this was the distance. This is 1, 2, 3 times greater. So my A value is 3. My stretch factor is 3. That's the equation for that. And I'm going to go ahead and erase that plus sign since we don't really need it. Okay, moving on to now we're doing some graphing. And what I have here is it says please state the parent function. Okay, well that's an absolute value, so the parent function is going to be y, so I use the f of x sign. It's already there. F of x is equal to the square root of x. That will also be what my parent function is that I'm going to use. So I'm going to go ahead and write that. Y is equal to the square root of x, and I'll have an xy chart for that. And I'll use the values 2, 1, 0, negative 1, negative 2, 2, 1, 0, 1, 2. Now let's go ahead and find the shifts and stuff for my shifted table. And the A value is going to be the multiplier. So that's a negative 1/4. That's my vertical shift. My vertical stretch. My H value will be opposite the sign that's with the X, so that'll be a +2, and my K value is 4. Now these blanks on the test will just be to help you put those numbers there and make it easier for me to see if you can get some partial credit. So let's go ahead and do some more. Now I'm ready to shift this graph. So I'm going to make my shifted XY chart. So the X value is going to increase by 2. That would be X plus 2. And my Y value is going to be a negative 1/4 times Y. That's the stretch, is negative 1/4 and plus 4. So let's pick these points that I had up here and plug them in. So 2, over here the X is 2 plus 2 is 4. Now I'm going to plug this 2 in, plug it into this equation. I get a negative 1/4 times 2. That's a negative 2/4. It's negative 1/2. Negative 1/2 plus 4 is 3.5. Plugging in the next value, 1. So I got 1 plus 2 for the X. And plugging this 1 in that I have for Y into this equation, I would get a negative 1/4 plus 4. That would be 3.75. Plugging the 0 in, I would get 0 plus 2. Plugging the 0 in on the other side, for the Y, I get 4. Plugging negative 1 into the X, I get negative 1 plus 2. Plugging 1 into this equation, well, I've already plugged 1 in once for the value right here. And you can see that I got 3.75, so I'm still going to get 3.75 when I plug 1 in. For the last point, a negative 2 plus 2 is 0 on the X, and I plug 2 in for the Y. Well, I only did that for the first point I tried, and I got a value of 3.5. So now this is my shifted graph, and let's go ahead and plot it. 4, 3.5. 1, 2, 3.5. 3, 3.75. Well, this is not going to be very easy to graph. And 2, 4. Now then, I got 1, 3.75, and lastly 0, 3.5. So I didn't pick a very good scale. That's what that's going to look like. Let's find the domain. See, the arrows are going out both directions, so the domain is x is equal to all reals. The range is going to be all values that are actually going down this way from the value here where y is equal to 4. So the range is y is less than or equal to 4. Let's do the next problem. Okay, this problem, I have a square, so my parent graph is y, or f of x, is equal to x squared. My a value is what it's multiplied by out here. That would be the multiplier for the y stretch. It's a -2. H is going to be opposite the sign. It's -1, and k is 6. Let's go ahead and make my parent table. And I'm going to have x values where I'm going to pick 2, 1, 0, -1, -2. And that would be y is equal to x squared. So when I put 2 in, I get 4. I put 1 in here, I get 1. 0, I get 0. -1, I get 1. And 4. So there's my parent. I'm going to shift that by, let's see, we're going to go x minus 1. And the y is going to go a -2. And I have plus 6. So plugging my points in. When I plug 2 in, I get 2 minus 1. That'd be 1. Plugging 4 into this, I have a -2 times 4. That's a -8 plus 6 is 2. Plugging 1 in for the x. 1 minus 1 is 0. Plugging a 1 in for the y, I get a -2 plus 6. That would be 4. Plugging 0 in for x, I get -1. Plugging 0 into this y, I get 6. Plugging a -1 in, I get a -1 minus 1. It's -2. Plugging 1 in, a -2 times 1, that's a -2 plus 6 is 4. Lastly, I plug a -2 in, I get a -3 for x. And I plug this 4 in to the y, and -8 plus 6 is a -2. Hold on, I think I made a mistake on the first one. Let's try this again. Plug 4 in, I get a -8 plus 6. This should be a -2. Also, when I plug this 4 in, the 2, 4 point, I get a -2 times 4. That's a -8 plus 6. This should be a -2. Now let me check this, the next point just to make sure I'm right. So I got a 1, plugging that in, a -2 plus 6. That would indeed be 4. So I think I've corrected my table. Let's plot it. 1, -2, 0, 4, -1, 6, -2, 4, and lastly -3, -2. So it's going to be this parabola. Okay, the domain, well, these arrows are going out to the side forever. And the range are all values where y is less than that point. So y is less than or equal to 6. Another graph. Okay, for this one, the parent function is going to be y equal to x squared, the square root of x. And for this, the h value is a -7, k is a -7, and the multiplier, or the y stretch, is 3. So let's go ahead and make my parent table. And for the square root, I'm going to use nice square roots. 9 would give me 3, 4 would give me 2, 1 would give me 1, 0 gives me 0. All right, let's go ahead and do the shift. So what I'm going to have is I'm going to have x minus 7, and the y is going to be 3y minus 7. The first point, 9 minus 7, that's 2. Plugging 3 in, I get 3 times 3 is 9, minus 7, I get 2. Plugging the 4 in for x, I get 4 minus 7, that's a negative 3. Plugging the 2 in, I got 3 times 2 is 6, minus 7, it's a negative 1. Plugging 1 in, I got 1 minus 7, negative 6. Plugging 1 in for the other side, I have 3 minus 7, that would be a negative 4. Plugging 0 in, I get a negative 7. And plugging this 0 in, I also get a negative 7. Okay, so let's plot it. I've got 2, 2, negative 3, negative 1, negative 6, negative 4, negative 7, negative 7. So here's my square root graph. And the domain is going to be all the x values. It'll start here and then we'll go out this way. So that's going to be x greater than or equal to a negative 7. And the y is going to be all values where y is increasing in this direction. So that'd be y is greater than also a negative 7. Next graph, we have a parent function. Let's see what we have. Cube root. Okay, so the parent function is the cube root of x. A is a negative 2. H is the value that is added or subtracted to the x underneath the square root, so there is no h. K is a negative 2. Alright, so let's graph this. My parent, y is equal to the cube root of x. So the points we're going to use will be nice perfect cubes. So I'm going to use 8. Cube root of 8 is 2. I'm going to use 1. The cube root of 1 is 1. I'm going to use 0. The cube root of 0 is 0. Negative 1. The cube root of negative 1 is a negative 1. And negative 8 would be a negative 2. Let's shift it. So we have x is not changing, and we would have a negative 2y, and it's minus 2. So plugging in 8 for x, I get 8. Actually, you can see the values for x are just going to be the same as in my table. Y values will change though. So plugging 2 in to this equation, I get a negative 2 times 2. That's a negative 4 minus 2, I get a negative 6. Plugging 1 into this equation, I get a negative 2 times 1 is a negative 2 minus negative 2, that's a negative 4. Plugging 0 in, I get a negative 2. I plug a negative 1 in, I get a negative 2 times negative 1 is a positive 2, minus 2 is 0. Plugging in negative 8 in, I would get, sorry, not 8, a negative 2. Plugging in negative 2 in, negative 2 times negative 2 is 4, minus 2 is 2. Okay, so let's plot that. 8, negative 6, 1, negative 4, 0, negative 2, negative 1, 0, and negative 8, 2. So that's my cube root graph. We can see it's been reflected and it's been stretched. Moving on. Okay, this is a cubic. Parent is x cubed. A value, that's what is multiplied in front of the parentheses. That would be 1, not 0, 1. 1 times anything is 0. H should be 4. K is negative 1. Let's plot it. Here's my parent, my points. So since it's a cubic, I don't want it to get large. So 2, 1, 0, negative 2, negative 1, negative 2. My shift. Okay, I'd be x and x plus 4. And my y value, it doesn't have a multiplier, so it's simply going to be y minus 1. So 2 plus 4 is 6. Wait a second, I didn't fill out my y values. 2 cubed is 8, 1 cubed is 1, 0, negative 2 cubed. What the heck? Negative 1 cubed is a negative 1. Okay, so let's go ahead. So if I put 2 in, I get 6. If I put this 8 in, I get 8 minus 1. That's 7. Putting the 1 in for x, I get 1 plus 4 is 5. Putting this 1 in for the y value, I get 1 minus 1 is 0. Putting 0 in for x, 0 plus 4 is 4. Putting the 0 into the y, I get 0 minus 1, it's a negative 1. Putting a negative 1 in, I get a negative 1 plus 4 is 3. Putting a negative 1 in for this y, I get a negative 1 minus 1, I get a negative 2. And I never did do my last point, so negative 2 give me a negative 8. Plugging a negative 2 in for x, negative 2 plus 4 is 2. And plugging a negative 8 in would be a negative 8 minus 1, that's a negative 9. So let's plot it. 6, 7, 5, 0. 4, negative 1. 3, negative 2. And then 2, negative 9. Not a very good drawn cubic, but that'll have to do. And let's do the domain and range. There's nothing that's keeping me from putting any x values in. They're going left and right forever, and we're going up and down forever. So x is equal to all reals. Y would be equal to all reals for the range. All right, moving over to writing the equation for a piecewise. So the first thing, it says f of x, and I'm going to go ahead and make my brackets. And the first equation I have is we can see that it's crossing the x-axis at 3. So b is 3. And the slope is I go up 2 over 3. So the slope is 2/3. So I should be able to write the equation of that line. That would be y is equal to 2/3 x plus 3. So that would be 2/3 x plus 3. And that would be if x, and we can see that all the values are x's less than or equal to this x value here of 3. So if x is less than or equal to 3. For the other little line, you can see that it's just the line y equals -2. And it's going to be for x values where x is greater than 3. All right, this last part is we just have to describe the shift. So real quickly, remember that if I have a graph and it moves its position anywhere, that's going to be the h and k. H is going to be what's with the x, but opposite sign, and k is going to be this shift here. That would be h is going to be, remember that's the h is moving the x value left and right. That would be vertical. And the k value is what moves the y. That moves up and down. So k would be a, I'm sorry. Let's try that again. The h value is moving x. So that's left and right. So h is going to be a horizontal shift. And it's going to be opposite the sign with the x. The k is moving the y value up and down. That would be a vertical shift. If this graph changes so that it flips downward, that would be a reflection across the x-axis. That occurs if the a value has a negative. A is the stretch value that's in front of the parentheses or anything. And the last thing would be a stretch or shrink. Now remember, a reflection here that I just showed you, that would be a reflection across the x-axis. We did not do any reflections across the y-axis. That would be where the graph flips from left to right. So there's not going to be any reflections across the y-axis in these problems. The last thing, it would be a horizontal or vertical stretch. That would be where this graph actually, the y value, which we the a value which we multiply by y, would cause this graph to stretch or shrink. And that would be a vertical stretch because we're stretching it vertically. We didn't do any horizontal stretches. That's where we're stretching it out left and right. So we didn't do any of those. We could just cross those off at each of the problems. So let's go ahead and do this. What we see is we have a square root, so the parent function would be f of x is equal to the square root of x. A reflection would occur if we have a negative on the a. There isn't a negative on the a, so there isn't any reflection. A vertical stretch or shrink. Okay, that would be the multiplier in front here. This is the a value. We could see that it is a vertical and it's greater than 1. So that means it's going to stretch the value. Greater than 1 will stretch it. So it's a vertical stretch or shrink of 2 times stretch. So we need to specify that it's a stretch because it could be a shrink. A horizontal shift, that would be going left and right. That's the x. We could see that in this case h is equal to a -4. So horizontally this is going to go 4 to the left. And vertically that would be the k. It's going to go up 5. Okay, that's that one. Let's go to the next one. Alright, first thing we see is what's multiplied by the x. That is an a value. If it was multiplied by the x as far as the c, which we didn't do, and any sort of shifts, that would be in the parentheses with the x. Like that would be a h value something like this would be an X stretch, and we didn't do any of those. We didn't do this kind, and we don't see that this 4 is not in parentheses, so that's a K value. So what we have is we have a parent function which is equal to x cubed. Reflection, yeah, see that negative? That means it's reflected, and it's going to drop across the x-axis, so it's reflected across the x-axis. We already said we didn't do any horizontal stretches or shrinks. Those would be the multipliers by the x like I showed you. A vertical stretch or shrink, yes, that's this 1/4. So it's actually shrunk. Horizontal shift, that's how it's shifted left to right. We already said that would have to be in parentheses, so there isn't any. The vertical shift is up and down. That would be the K value, so this would be going for up. Next problem. The parent function would be x squared. A reflection, there is no negative on the 3, so there is not. We don't have any horizontal stretches or shrinks. That would be a multiplier by the x. A vertical stretch or shrink, yes, that's the A value here. It's a 3, so it's going to be a stretch because it's greater than 1. The horizontal shift, okay, H here is a -2, so this would be moving 2 to the left. The vertical shift is up and down. That would be the K value, and K is a -7. So this would be going 7 down. And I think the last problem, finally, is the parent function would be the absolute value of x. The reflection, there is no negative. So the reflection, there is none. Horizontal stretch or shrink. No, we're not going to have any of those. Vertical stretch or shrink. This is a 1/2. That means it's going to shrink. So it's a shrink by 1/2 times. The horizontal shift, well, that would be the H, and here we have H is equal to 3, so this would be 3 to the right. And the vertical shift would be K. Well, there isn't any K, so there is not going to be any vertical shift. Good luck on the test.